Hello and welcome to the AgriHub INSPIRE Hackathon kickoff webinar. My name is Anna Kubíčková. I am going to be your host today. And during this special webinar, our mentors are going to have a pleasure to introduce you to the objectives of all 8 very relevant series of challenges that have been defined for this hackathon. And additionally, you will also learn about how to join this hackathon as a participant. But before that, I would like to introduce you to the hackathon itself. The AgriHub INSPIRE Hackathon is already the 19th INSPIRE Hackathon organized by Plant for All Association, and already the 5th one that is organized fully virtually. And why is this hackathon called AgriHub? This hackathon takes place within the AgriHub CZ&SK project funded by SmartAgriHubs. SmartAgriHubs is a European project under Horizon 2020 and brings together a consortium of more than 164 partners in the European agri-food sector that aims to realize the digitalization of European agriculture by fostering an agricultural innovation ecosystem. The AgriHub CZ&SK project, therefore, aims to support agricultural digital innovation hubs for the Czech Republic and Slovakia and facilitate the establishment and implementation of innovation experiments. The main idea of this 12-month project is to integrate the activities of existing innovation hubs in the Czech Republic and Slovakia, namely AgriHub CZ and AgriHub SK, and to support the interaction of farmers, advisors, machinery manufacturers, researchers, or developers in order to move Czech and Slovak agriculture towards smart farming. In the frame of this project and via this digital innovation hubs, we aim to build and develop the knowledge base, build and support the agri-food community. Via these digital innovation hubs, we also aim to provide a space for data and technology infrastructure services. We also aim to publish the latest outcomes of innovation experiments. Then it will be also a place for education and training. And we also need to think about communication, sustainability, and development. A total of 8 organizations from Czechia and Slovakia have joined together to support the establishment of a digital innovation hub for Czechia and Slovakia and to support this idea. The project has identified 7 innovation experiments that focus on selected use cases with the potential to create new products or services. AgriHub CZ&SK project will support the development and communication of these innovation experiments during the organization of hackathons. And that's exactly why we are here today, because AgriHub INSPIRE Hackathon is the first hackathon organized in the frame of this project, and it will support the development of these innovation experiments, which are called challenges in this hackathon. Now I will tell you a couple of words about some organizational aspects of this hackathon. The hackathon takes place from November until the 15th of December, when the final event closes the entire hackathon. During the final event, all results will be presented and the jury will select the top 3 teams who will get the opportunity to contribute to peer-reviewed articles and citable publications documenting the outcomes and results of the winning teams. For all participants, the main benefit of joining the INSPIRE Hackathon is the opportunity to access and become a member of international community of practice and get the opportunity to participate in European projects. To achieve this, you need to register for the hackathon and join one of the teams. The registration for the hackathon is open, so if you like the particular challenge you are going to hear about very soon, you can register for the hackathon immediately. After registration, you will receive the invitation email from the mentor of the challenge, and then you can start hacking with the team. Before we move to the first presentation, I would like to remind you that we have a chat available for your questions, or you can raise your hand and ask our mentors directly. That's all from my side for the moment, and we can move on to the first presentation of the challenge. We will start a little unconventionally with challenge number 4, called Irrigation Management, that will be introduced by Jakub Fuska from Slovak University of Agriculture in Nitra. Jakub, are you ready? Jakub, are you here with us? Okay, if not, I would recommend to start with the presentation called Crop Detection, which is challenge number 2, and it will be introduced by Karel Charva. Okay, Karel, the floor is yours.
Okay, do you see my screen?
Yes, we do.
So I would like to introduce the challenge 2 and what are our intention in the challenge 2. We will work with Sentinel-1 and Sentinel-2 data, and our focus is to select the best way how to monitor crop status. So we will be very happy to cooperate with other, and now I will try to tell you a little. So the focus will be on the combination of Sentinel-2 and Sentinel-1 data for temporal and spatial variability analysis in the crops, and the one goal is to select the best indexes which are able to give us the best combination of the data for detection of the situation. We are trying more and more to deal with Sentinel-1 because the problem with clouds and Sentinel-2, for example, in this season, there are almost no images, but on other side, the working with Sentinel-1 is much more difficult. So we will be very happy to share our knowledge and experiences with other team and to cooperate on the development. Here you can see the comparison of different indexes. The 3 images are from Sentinel-2. This one, which noise is from Sentinel-1, and this is the main reason why we need to do much more tests with Sentinel-1 to be able to use this for monitoring of the crop status. You can see, for example, here what we already done in the past. It is the development of this index during the season. So there are some trends which are similar, like in Sentinel-2, but the analysis are more difficult and it is not so easy like with Sentinel-2. What is one from the goal is to be able to generate some management zones from the data, which can help us in the future to optimize usage of fertilizer. You can see again here some tests with different type of the data, how these zones can be generated. So we are looking not only for Earth observation or IT expert, but we will be very happy to have with us, for example, farmers, but also we are looking for the people dealing with business who will be ready to discuss with us the best model for utilization of this technology. The goal is to move some from this analysis, which till now we done on the desktop to our cloud. So we have here number of tools which is possible during the hackathon to use on our cloud, and there will be support during this hackathon for both for the data but also for the technology from our team. So this is shortly about this challenge. I would like to invite anybody, please join us, start to work with us, because we see us this as very important, mainly now with the Green Deal, and if the Green Deal will come to the force, farmers will need to have better information from the satellite images, and this challenge can help with develop new methods. Okay, this was...
Thank you very much, Karel, for introduction to the challenge number 2, dedicated to crop status monitoring. And now you can also present a challenge number 8, because you are also a mentor for use cases for Whiteboard. So the floor is yours.
Okay, so I will start with challenge number 8. Now you see my screen, please.
Yes.
Okay. This challenge is a continuation of some development which started already many years ago. This challenge about this whiteboard development started already on the INSPIRE Hackathon in Barcelona. It was 2016, and meantime we done, I think, very good progress with this technology, and now really the idea is to find the new cases for this technology and turn this technology to the business. At the beginning, what is Map Whiteboard for the people who never heard about this? It is a very new concept for working with spatial data. Yes, anybody from you know Google Documents, or now there's many alternatives for the documents where the people are able simultaneously work from different spaces on one document. Why don't do the same with the maps? Yes, and this was the first idea many years ago to come with a similar solution for the maps, and we start together with colleagues from Norway and Latvia to develop this technology. Now this technology is I think advanced, and it is running. We in last hackathon we made a number of practical tests with a number of users. There exists the backend and front end for this solution, and now we would like to continue with this and to really be focused mainly on how to turn this Map Whiteboard into the business. Yes, so first is to be able to discuss new business cases where this collaborative technology can be used. We are thinking, for example, about communication of advisor with farmer, but probably there could be also other possibilities. And there were already some business cases recognized in the past, and we would like to further develop these business cases. One potential business case is, as I mentioned, communication between agriculture advisors and farmers, and of course it could be also used for collaborative data capturing. We see this as a very excellent tool for now so popular citizen science. So anybody who is interested on the technology side or on the business side will be welcome to join our effort. Yes, and during the hackathon, we plan to organize practical demonstration and testing. We will organize some webinars where it will be possible to collaboratively work on some maps. We would like to run some brainstorming about potential application and to try to integrate it current version of the Map Whiteboard with some existing application, and to design new application, and of course to develop some business models. Currently there are two possibilities how to use these things, and one is the web client, which is based on edge layers, and this client allowed the editing. Other possibility is that we have also some plugin for desktop client for QGIS, and there is also possibility to use the QGIS as the client for this collaborative work, so more people can sit with the QGIS connected the server and provided editing from the desktop solution. And there could be potential for a number of applications, for example, in QGIS and other what we could do, and this is where we would like to have more people to collaborate it with us. So please join us, and this Whiteboard challenge was Map Whiteboard challenge was winning on last hackathon, where we ran this large-scale demonstration, and now we would like to extend this more, and we are looking for collaborators who can help us to turn this solution into the business. So it is all from my side about our two challenges, where I will be one from the people who will help to run this experiment and to go to some solution.
Thank you very much, Karel, for this very nice introduction to Map Whiteboard. And now I am giving floor to Jakub Fuska from Slovak University of Agriculture in Nitra to introduce challenge number 4, irrigation management. Jakub, the floor is yours.
Okay, hello, can you hear me now?
Yes, we can hear you.
Okay, that's great. So I'm gonna share my screen. Now, please let me introduce our presentation of experiment number 4, which is called irrigation management. Can you see my presentation, please?
Yes, we can see it.
Oh, okay, thank you. So, main task of our experiment is to help the farmer with the useful information. How much of water does he have available for the irrigation right now in his water reservoir? The water amount in a reservoir is changing under the condition of weather and also consumption of water for the irrigation or other purposes, but also it is affected by the discharge or recharge from the watershed of this water reservoir. Our idea is to create some very simple web app that will display the current water depth of the map, reservoir, and also available amount of water that is currently stored inside this water reservoir. The advanced idea, what would be done or what could be done, is to implement the data about watershed morphology and land use and land cover inside this watershed, and also the development or prediction of rain events or incorporation of this data in this model. Also, the current data of watersheds, such as temperature and soil moisture, should be or can be utilized to provide the most accurate version or information of what are the potentials of the irrigation in forthcoming few days. We have chosen the study area here in Slovakia, where the water reservoir near city of Nové Zámky is located. It's called water reservoir in village Maňa, where we have available data as a DEM of water reservoir bottom and also the DEM of water reservoir watershed. The bottom reservoir DEM was calculated from the input data that was collected by sonar and GNSS survey, and then the creation of raster digital elevation model of the bottom was created. The watershed DEM is calculated from the national datasets. We have 2 available datasets currently for the usage, and this is a 10 meter pixel for the first one, and also 1 meter pixel created from the LiDAR survey from the last year. The principle of calculation of water amount is to create the water level or create the DEM of digital elevation model of the bottom and to create the water depth map. Then we are able to calculate the current water storage. But the current water storage is changing due to the fluctuation of water level, which we are able to survey with the use of a very simple Arduino prototype that was built as a part of diploma thesis of one student. This was done in the year 2018, and we are trying to incorporate this data or this system to the different tasks which can be done. Water storage currently can be calculated in various ways with the use of GIS tools, and we are trying to get this data to the farmer as a part of a web page or mobile app. The calculation should be done within the server application, which could be prepared in various Python or other GIS libraries, and also with the use of various free and open source tools to provide the cartographic outputs. Then we try to go a bit more smarter with the hydrological modeling, with incorporating of the weather forecast, land use and land cover usage, soil type and texture data, or soil moisture monitoring. Those parts are dealing with the or can be provided from various data sets. Some of them are available openly. So this would be the task that we are going to deal with. I hope that if someone finds this topic interesting, that they can freely contact me, and I will try to do my best to provide them with the information, and the hacking part of the hackathon can be done to provide this information. That's all from me. Thank you
very much. Thank you very much, Jakub, for this very detailed introduction to the challenge number 4. So if you like this challenge, then do not hesitate to register for the hackathon. I've just put the link for the registration into the chat. So now it's time to move on to the presentation of the challenge number 1, which will be introduced by Herman Schnevais from Plan for All. Herman, are you ready?
Yes, I hope you hear me. So I will start sharing my screen.
Okay, great. We can hear you and see you.
Yeah.
And now we can see also your screen.
Perfect.
Go ahead.
Yeah, I will just put, yeah. Hello, everybody. It is my pleasure to introduce to you challenge number 1. The name of the challenge is crop detection, and mentors are me and Mrs. Batrolova. We are doing this challenge based on previous hackathons, based on previous achievements we've done on the previous hackathons, and the challenge is about detection of field or crop data through satellite images. And on previous hackathons we've done multi-temporal classification based on 2 vegetation indices, one from Sentinel-1 and one from Sentinel-2. And we also have done some accuracy measurement. So there are some basics we can build on. And what are next steps we are going to do on this hackathon? We want to improve or make some trials with different data sets. We can use, for example, moisture indices to detect a crop on the field. And we can also pre-process data by unsupervised classification, and then use the supervised classification for crop detection. And there is a idea or hypothesis that it could help the accuracy of the classification. Then also important thing is classification based on Sentinel-1 data, but the accuracy of this classification is not very good. So we could also improve the classification of Sentinel-1, and we can also do this by some pre-processing of the data or some other improvements. And also next idea we could improve the classification is to find some application of the results, which are very important, maybe the most important from all the things. because we need to find some ways how to sell or how to make impact on reality from this useful data. So I think there were a lot of sites which could be improved, and there is business side, there is some technical side. We also look for some people from agriculture. So if anybody is interested in this topic, feel free to register to this challenge or write me an email, and we will make some collaboration. Thank you.
Thank you very much, Herman, for the introduction to the challenge number 1 and also for sharing the contact details on you. And now we can move to the presentation of the challenge number 3 that will be presented by 2 mentors, Martin Tuchyňa and Marcela Gergelová. So Martin and Marcela, the floor is yours.
Okay, good afternoon, everybody. Can you just confirm me that you can hear me and see the slides?
Yes, confirmed.
Perfect, excellent. Thanks a lot. And also from our side, as already said by Hanka, we would like to share with you some really brief intro to the challenge 3 called Agro Environmental Services. And we will split it between 2 of us. So I will try to open the initial part, and then I will ask Marcelka to share with you the second part of the challenge. So what this challenge is about, in principle, we would like to really get hands on the data and identify the data related to the domain of agriculture and environment in general, and see what is already available now and what we can somehow stimulate to become available soon. And at the same time, the second main ambition of this challenge is to actually take some of those data and build on top of them some really use cases which we will try to identify, we already identified, and to demonstrate their potential use. So what we would love to do is to really have a look on the publicly available data from the initiatives you can see on the slide. Of course, aside of the geographical focus towards the Slovakia, we would also like to see some potential synergies with some cross-border exchange of data, ideally also from some input from Czech Republic. And we have also some sort of sub-pilot area, which is located on the southeast Slovakia in the region of Medzibodrožie, and we will come to that in a second. So we have identified the goals and some sort of outcomes, and those goals we split it to sort of 4 possible use cases we would like to support via this challenge. And the first one is really, we called it data inventory, and to really provide some sort of review of what may be made available with our and hopefully your support. The second one goes towards the so-called blue layer, especially towards the artificial water canals, where we would really like to see whether we are able, with the data made available, to analyze some changes in time, and to see whether these changes can also help us identify possible crops irrigation, or identify the aspects related to the drought or flood protection, or to see whether these canals could be in the future turned to the new type of usage, which will be really useful for the target region and area. The other 2 use cases goes more towards the sort of analyzing and the possible utilization of these data resources. So the third one, we would really like to actually look on the data themselves and compare the available data, and to see what's their quality, what's the semantics behind, and whether there are some gaps or some overlaps which would be good to improve towards the future. And the last use case, here we would really like to see how we can put together spatial and non-spatial data. And what would be the outcomes? For the first use case, we really do see that there will be at least metadata harmonized and made available, and ideally metadata with real linkages to the data themselves via services or APIs. And for the second use case, it would be great to have on the end of the hackathon some really land cover or land use changes layers with some sort of evidence what might happen in time around the target region, and also to see what might be possible to do with such outcomes of the use case. And for the last two use cases, for the third one, we are looking forward to see whether we can combine the data from a Slovakian sort of database used to collect information about the European funding. It's called ITMS, and to combine this data with the cadastral or land parcel information system data, and to get some sort of new additional added value out of this sort of merging and combination. And last but not least, for the use case 4, we would really love to get really hands dirty from possible joining of the spatial and non-spatial data as on local machines, but also using the potential of semantic web technologies. And with that, I give floors to Marcelka to guide us through the rest of the challenge.
Thank you, Martin, so much for your information. For target users, we have initiated communication with the public sector. We have also close cooperation with self-governance sector, in particular the Košice self-governing region. And we will try to direct this challenge to a level that we also attract or recommend this private and academic sector, universities and research institutes. For possible direction, or for possible directions, we are currently trying to clean up agro data sources, mainly through metadata. And you can see a list of data sources inputs in which we are considering in this challenge. And we would be very happy if somebody give us some other data sources which are not on this list. And this part of the presentation, how it could be take place with this challenge, more or less it is initial potential, and it depends on the data, what will be evaluated with what, and also depends on the basis of chosen methodology. Our expectations are that we are looking for a group of interested persons, such as agriculture and environment experts, anyone with evenness in this area, or for any enthusiast willing to contribute. For challenge number 3, Agro-Environment Services has following team behind presented at this slide. And if you are interested in, please join us and contact us at mail addresses below. Thank you so much for the attention.
Thank you very much, Martin and Marcela, for introduction to the challenge number 3. I am still keeping my eye on the chat, and I can see that Mr. Ahmad has a question: where will the recorded lecture available sent on my Gmail? As you could probably notice, this webinar is being recorded, and after it ends, the recording will be available at Plan for All YouTube channel, and also we will send you the recording via email. Thank you very much, Mr. Ahmed, for this question. And now we can continue with the challenge number 5, dedicated to extreme weather. This challenge will be introduced by Teresa Shamanova from Czechia. So Teresa, the floor is yours.
Yes, Hanka, thank you. Thank you very much for your nice words. I hope that you can see me for the moment, and in a second you will also see my screen. Yes, so now you should see the first slide. Is it okay?
Yes, everything's fine.
Yeah. So I would like to start where Marcela from Technical University in Košice has ended, because of course in our challenge as well, similarly as within the others, we are looking for enthusiasts, we are looking for technology experts, we are looking for those who have very good ideas how to solve the problem of extreme weather. Just to introduce my organization, Czechia is a coordinator of one digital innovation hub that is not exclusively focused on agri and food sector, but we are grouping lots of companies, researchers, and those who are active in the field of data analysis, using AI tools in practice, using some robotic solutions, and this all can be also very successfully used within our challenge number 5, extreme weather. So just to introduce where we are and where are we moving. Of course, these negative consequences of extreme weather do bring sorrows to all of us, and those who are most concerned are agriculturers and those who are dependent on the results of agriculture production. So all these negative experiences that can be seen on this slide are merit of this challenge. So we would like to have a look at the droughts, floods, storms, some extreme temperatures, extreme droughts, and extreme rains as well. Of course, these events and these unusual weather situations are getting quite more and more often due to the changing climate worldwide. So we would like to use some more digital technologies in helping to prevent from the negative consequences of this extreme weather actions, and would like to help prevention from devastating impacts on agriculture, help to quick recovery after the extreme weather events, and help to prevent also the economic damages. Why we would like to use more digital technologies? Because using new hardware, using new data models and new thoughts that can connect the existing solutions with the new ones can help all of us, especially those who are active in the field of agriculture and food production, and all this together can help us to have more colorful market and more reliable market with agriculture goods and also with food. So this is where we would like to help. Which tools do we have to our disposal? You are, of course, well aware about Copernicus possibilities. There is a emergency management, there is a flood awareness system, a drought observatory that can be found on the website of Copernicus emergency management system. But we would like to enrich this data that is publicly available with new tools based on artificial intelligence, by new data models, also possibly by new hardwares like robots, including drones, by some sensors, and also by other data that can be collected from volunteer or accessory observatories, from citizens, and from volunteer geographic information. We would like to validate, assimilate, and train observatory systems and complete the missing observations using these data. And the final aim of our challenge, and I'm getting back to the beginning of my presentation, is to help to prevent the damages caused by extreme weather, to manage acute states when solving the extreme weather periods and extreme weather actions, to deal with its negative consequences, not only for the crop production, but also economic consequences caused to the markets. And we would like to use more digital technologies to prevent crop diseases, to help growth monitoring, and to avoid at the end damages on growth and soil, and of course, in a consequence also to the economy. So that's all about the initial presentation and the introduction of our challenge number 5, extreme weather, and we'll be happy to get more enthusiasts, technologists, researchers that would join our team and enrich the brainstorming on the topic of extreme weather. Thank you for your attention.
Thank you very much for this very nice introduction and invitation to the challenge number 5, Teresa. And now it's time to have a look at the challenge number 6, drones utilization for crop protection, that will be presented by Miroslav Konečný from AdSen. Miro, are you here with us?
Yes, I'm here. I'm just setting up my slideshow. So can you see my screen?
Yes, we can.
Yeah, perfect. Okay, so I will present the innovation experiment number 6, which is about drones utilization for crop protection. As you may know, the drones are heavily used for any applications in the field, in different fields. However, in the agriculture, it's not so common at the moment. We see that there is a major problem, that the health analysis and the efficiency and the analysis leading to efficiency evaluation are mostly about the experience of the farmer, and they are not supported by some objective instruments. The health diagnosis at the moment is via the knowledge of the agronomist, and the long-term soil and climatic information is not used. There is a clear absence of the unified procedures and methodologies for reliable decision making. There is a great opportunity. So we see that as this diagnosis is not accurate enough, however, there occurred new innovative methods for identification and location of specific objects, and also there are advanced technologies under development in the field of the agricultural machinery, including drones. We see that a lot of technology exists, and it needs to be utilized for specific scenarios. We see that there is a call for 2D and 3D image processing systems. And we see that there are many initiatives in the research field. However, they were not transformed yet into practice. We see that the cost and productivity of the specific applications, including the agriculture, are getting, the productivity is getting higher as soon as these are used for specific application, including the mapping of agricultural areas, specific objects, and their contribution for standardization of the detection and control systems for decision support. This is an example of the application. So it's an image from crop tracker. Sorry. So this is an example of the technology used in specific conditions. As you can see, the system can recognize the areas with less water, and which leads to poor productivity of the crops. The expected outcomes of the innovation experiment are in a way in the utilization of the existing hardware and software. So we want to use the commercially available unmanned drones. So we don't want to reinvent the drones in themselves. We are seeking for systems that are able to determine the coordinates of the region together with geometrical dimensions, and they can provide accurate information in form of maps with identified insufficient moisture, weeds, pests, and diseases, or with low nutrient concentrations. The second expected outcome is the methodology that will be able to identify the problematic areas of selected crop. It will result into the measured data, whether in imaginary form or with hands-on decision support system. And also, both of these expected outcomes will lead to an intelligent system for support the decision-making of the farmers. They will be able to make automated assessment of measured and collected data, and also this will be projected into the mobile application with precise localization, and can be used in the field. So who are the target groups? And this is my invitation for cooperation. So we are seeking for farmers and food production system actors who can benefit from the service in the form of increased productivity and efficiency of their work. And we are looking for farmers that want to become target groups or actors in the experiment. And second, the second primary target group are service providers who already have some of these systems and want to use them in concrete conditions in Czech Republic and Slovakia, and they are seeking for new economic opportunities in this field. The secondary target group are the research performers, such as universities, R&D companies, and government bodies, which can use the outcomes for education, research, and development of their knowledge base. The data involved in the innovation experiment with drones are the LPIS data. So it's land parcel identification system data, weather data, and the drone data, historic data from drones, or also the data collected via the experiment itself. These are the 4 challenges that we have in the hackathon. Hackathon is the first stage of the innovation experiment. So we will be working on the scoping of the innovation experiment with users for concrete use cases. Also scoping for with the providers when we want to match with the existing technologies and define a tangible step forward. Third, we want to identify concrete data sources available for the case. And fourth, we want to define the success criteria for the business plan, because this is an innovation experiment that has to, it's not so much about research, but it's more about development for concrete applications. And we see that it has to fit also with the business plans. What is the timetable of the experiment? So we start with this hackathon activity with the goals as defined previously. Then in the early 2022, we continue with the methodology development and improving the methods for data analysis. In March, we want to finalize the apps design, defining types of final applications for users and the final data used and integrated in these applications. And from April to June, we want to support the apps development, testing, and updating, and also the business model development for the participants of the innovation experiment. We have 2 leaders of the case. I'm one of them. I will support the management of the case and the exploitation path, while Zuzana Palková from Slovak University of Agriculture in Nitra is the author of the innovation experiment concept and technical delivery. So she's the contact person for technical questions. Yeah, and that's it from me. Over to you, Hanka.
Thank you very much, Miro, for sharing with us the expected outcomes of this challenge and also to the introduction of the objectives of challenge number 6. And now we are slowly moving to the end of the webinar, to the very last presentation of the challenge number 7 that is dedicated to analysis, processing, and standardization of data from agriculture machinery for its easier utilization by farmers. This challenge will be introduced by Pavel Gnip from Agro. So Pavel, the floor is yours.
Thank you, Hanka. I'm Pavel Gnip. I'm working for Agro as a specialist for precision farming technology and adoption on the farm. Today, I would like to introduce the challenge number 7, machinery monitoring. So I would like to go through and describe a challenge what we are asking for. So agriculture machinery is a significantly influence for any farm work. So how farm operate machine on the field, it's everything depend on the product quality and economy and the other things. So these data are very important, and its monitoring is helping the farmer make a quick overview and fast decision for next work, of course, and summarize of his work in every year or any time. So from the technical point of view, the monitoring system involves tracking of the vehicle's position in using a GPS combined with acquisition of information from onboard terminals or some field sensors. So it could be a CAN bus or ISO bus or some other bus. And they online or offline transfer to GIS environment on the ISO XML format. We would like to focus on open format, so ISO XML is a good one to work with. Verification process. Verification of the data collection will be done at the medium-sized farm. So we would like to collect data, and we already collected data from medium-sized farm as we use as a pilot farm for our precision farming technology we apply and sell on the market. So similar monitoring of weather data, we will test it on the enterprise, which is offering service for farmers for assessing the quality of work for customers. Example, evaluation of economic efficiency of machinery operation within the field on the farm. So every field has a boundary, and we would like to collect the data inside the field and use another analysis, just focus it on the field. Precise record of crop management treatment. It's going with another limitation and restriction from, for example, from the government and against to other specific place. We don't want to, for example, apply the fertilizer or chemicals. Management of machinery operation or control of requirements for field operation. So control pass to pass, how was working on the field and work was done. Control of applied input materials in comparison to prescribed rates. So we work with some prescriptions which are created on already what was done and some news and new information. So we would like to also check if it's really done or how was it done on the field due to conditions. So another online monitoring of the weeds or online monitoring of the weather. This is just an example of the data cell we want to go for. Challenge of goals. I just set the 4 examples as is visual tracking the machinery fleet, evaluation of economic efficiency, or evaluation of machinery passes on the soil environment. This is, I think, one of the most important things, but also the open for future update and local changes that the database is going to be improved in the time and according to I don't want to say restrictions, but maybe recommendations, which we want to go for more healthy agriculture product and keep the good environment around us. So this is the most focus on. Which data are available already for this case? ISO XML file from tractors offline. These data or same data could be available also online from tractor. And as an example, as I said before, the weather data in ISO XML format. So these three groups of data we have available from the farm, and we want to continue on that. If you need more information around, please contact me on the email. Thank you very much for your maybe participation on this challenge, and thank you for your attention.
Thank you very much, Pavel, for the introduction to the very last challenge of this INSPIRE Hackathon. And now I am giving floor to you. If you have any questions, do not hesitate to unmute yourself and ask our mentors, or probably me, with some organizational aspects of this hackathon. And while you think about your question, I would like to highlight very important thing, which is that the INSPIRE Hackathon is not the event, it's a process. As you may have already noticed, some of the challenges were defined in the previous hackathons, and in this hackathon we are moving forward the results of the previous hackathon. Some of the challenges were identified for the AgriHubs and CZ project, and we will continue with developing the results and for finding the results in the spring INSPIRE Hackathon that will be organized next year. If you want to move forward the results of the previous hackathon or build a new one, then do not hesitate to register for the hackathon. Just visit planforall.eu website and register right there. Martin raised his hand. Martin, do you have any question?
Yeah, thanks a lot, Hanka. I just wanted to ask if we will see that there will be some sort of linkages between the challenges. Is it foreseen to have some sort of shared space where we could, for example, share the data or let's say partial outcomes, or it's preferable to contact the leaders of the challenges via email? Thanks.
Okay, thank you very much, Martin, for this question. We always recommend to all mentors to create a Google Drive or some another shared space where mentors and team members can share the current results and share their thoughts. So I would recommend to participants to contact a mentor about their interest to cooperate on the challenge, and then the mentor will invite you and share with you the shared workspace. Was that enough for you, Martin?
Yes.
Was that a good answer?
Yeah, definitely.
Thank you. Do we have any other questions? If not, I would like to remind you all about the recording that will be available at Plan for All YouTube channel. For those registered participants, we will send an email with the recording. And yeah, I would like to thank you all for your participation. I would like to thank all mentors for the introduction to their challenges, and I am looking forward to meeting you in the hackathon. See you.
Yes, thank you very much. I'm looking forward to your applications into challenge number 5. Goodbye.
Thank you. Goodbye.
Thank you. Bye-bye.